Hi everyone. Now that we've finished up our section on motion, speed, and acceleration, it's time to talk about one of the fundamental principles of physics, and that is force. I know when I say force, some of you will think of our friend Yoda, may the force be with you, yet others of you will think of ancient aliens and midichlorians. But keep in mind that midichlorians and Yoda really don't have anything to do with the force. When we consider what the force is, it has a really straightforward definition. It is defined as a push or a pull. One of the cool things about force is that it has two fundamental characteristics. One is that all force has direction, and the second is that all force has magnitude. Now, this being science and all, we can't do anything the easy way, and we have to have our own special unit when we describe and when we measure force. The unit that we use is called a Newton. No, it's not fig Newtons. It is, in fact, named after Sir Isaac Newton, who was one of the leaders in early physics. You'll notice that Newton is abbreviated with a capital N. One of the things that I like about force is that I find it to be pretty easy to work with. You can add it, you can subtract it, and it's going to look something like this. When we combine our forces, the way that we start out is we are going to indicate a force with an arrow. Right here, what I have indicated is this blue arrow right here, which is 5 newtons. Now, if my computer were cooperating with me, there we go. I've got this other arrow here, which is 5 newtons. So I have these two separate forces here, and when I add them together, what they're going to do is they're literally going to add up. So a 5 Newton force in this direction plus a 5 Newton force in this direction is going to equal a 10 Newton force in the same direction. Let's say, for example, we have a 10 Newton force going the opposite direction, and we want to add it to a 5 Newton force going this way. We're literally going to add the magnitude of these forces, and you'll see that we end up with 5 newtons going the same direction as the stronger force, or the force with the greater magnitude. Likewise, if you have a 5 Newton force going this direction, and you add it to a 5 Newton force going the other direction, they are in effect going to cancel each other out, and you're going to get 0 newtons. Now we call all of these things here the net force. So when you combine two or more forces together, the end result is something that we call a net force. Now these net forces will always act in the direction of the greater force. You'll notice over here when I have 5 newtons going to the right and I added 10 newtons going to the left, I ended up, my product was 5 newtons going to the left. That's why these arrows and the directionality of force is really important. The arrows, the directionality, the magnitude, all of this together, when you're combining forces, can tell you a little bit about whether forces are balanced or unbalanced. One of the things that I want you to think about is a seesaw. If you have two people of equal mass sitting on either end of the seesaw, it's not going to move anywhere. But if you have a really big person and a really small person, the seesaw is going to move in the direction of the bigger person. And that's exactly what force is all about. The force will move in the direction of the bigger force. Okay, so net forces, they tell us two principles that we need to be comfortable with. This first one, when I told you about the seesaw with the big person and little person, we would consider that to be unbalanced because the forces, the net force isn't equal. So unbalanced forces acting on an object will result in a net force, and that net force will cause a change in the object's motion. What this looks like, here we have this little guy here. He's applying a force to an object. His force has the direction of moving it to the right. The resultant motion is to the right. Now let me show you what an example of a balanced force will look like. A balanced force will act on an object, but they won't change the object's motion. For example, if you have two people who are pushing on this same box, you could see these vectors down here. These arrows are representing the force, both the magnitude and the direction. You see that both of these arrows are the same size, but they're going in opposite directions. The net force is going to be zero, so that object won't move at all. We consider that to be a balanced force. Okay, so where does that leave us? That leaves us with this summary right here. First of all, force has both magnitude and direction, and we do measure them in this unit called newtons. The second thing is that force can be represented by these things we call vectors. Vectors are just quite simply arrows. And remember, your arrows have a different direction. So that's your direction, which way they're pointing. And then it also has how big they are, and that's your magnitude. A bigger arrow has a greater magnitude. A smaller arrow has a smaller magnitude. A key piece here is that forces can be combined. And when you combine them, you end up with something called a net force. That net force is always going to act in the direction of the force with the greater magnitude. And finally, this is, I think, one of the more difficult concepts, is the fact that the net force can be balanced or unbalanced. In class, what you're going to be doing is seeing several examples of balanced and unbalanced forces, some of which I think will really surprise you. And that, my friends, in sum, is the nature of force.